All right, today we're going to be going over how to graph linear reciprocal functions, linear straight lines. We are going to talk about quadratic next class, but for today we're starting with this idea of like reciprocal functions. You probably heard that word before. Remember when you're doing let's say perpendicular slope, and so the slope is like 2 and the perpendicular would be like -1/2. That would be the negative reciprocal. Reciprocal just means like flipped upside down. So if it was 1/2, it becomes 2/1. So basically, reciprocal graphs are going to look like this. Instead of graphing something like this, it becomes this. So remember last unit when we were doing all the stuff with the x on the bottom on the denominator? We're now going to graph these. Now, just so you get a heads up, it looks like this. It's really weird, but once you kind of get the basics of what to look for in that weird curvy graph, it's not that bad. All right, that being said, let's start with some basics. Today you need to know how to figure out what asymptotes are in an equation and also how to graph it, okay? So the first thing we gotta know is what's an actual asymptote. So I'm just gonna scroll my example graph for a sec. If you look at this graph, the red line represents the actual graph. It's never actually going to touch here, and it's never actually going to touch here, okay? The graph is never actually going to touch those 2 points. Those are called asymptotes. Those are special lines, and they're values that the graph will never have. They'll get very, very close. As you can see, it's going to get very, 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 very close, but it'll never actually touch it. So the way that you can tell what the asymptotes are they basically the MPVs, which is what we figured out last unit. So looking at this, you know that x cannot equal 0, as we see right there. So when we graph this, x cannot equal 0 is going to be an asymptote. At x equals 0, there's going to be like a dotted line where the graph will never actually touch, okay? The other value we have here is y. Y can't actually equal 0 either because of the way the equation's set up. And in most of these, actually all of these, y is going to have an asymptote as well of y equals 0. So when we actually graph it, the trick is that you imagine it's not reciprocal. So this would be the actual question. We're going to try graphing it like this, as if there was no like 1 or fraction part. So y equals 2x, that's pretty easy to graph, right? Starts at 0, goes up by 2 every time. Cool. Yay. Okay. So now what we're going to do is we're going to actually put the asymptotes. So we figured those out already. That was x equals 0 and y equals 0. So I know y will never equal 0, so I'm going to put a line here. And I know x will never equal 0, so I'm going to put a line there. Now what we're going to do is we're going to take all the points that we found, all these points here and here, and we're going to make the reciprocal values. So see this point, the y is equal to 2. The reciprocal of that would be 1/2. So that point I'm going to change to 1/2. And then the next one we look at is at 4. So again, that's going to become 1/4, which could be even smaller. The other thing that you can do if you want, actually let's keep finishing this, and then this could be even smaller, so we get this curve. Okay? Remember, it's never actually going to touch that asymptote. We do the same thing over here, so we take that and reciprocate it, becomes 1/4, and again, we get a curve like that. The last thing we can do to finish out this curve to make it a little easier is we can actually take a ruler. This is so fancy. Okay? Put it along the points, draw our line, okay? But what we're going to do is that this line isn't actually right. The only point on it that is right, I'll make it green, is where y is equal to 1. That point is an actual value on our absolute value graph. And the reason for that is when we look at the graph, if it's y equals 1 and y equals 1/2x, that value had to be something so that it'll equal the graph as being 1/1. So basically what that means for you is we found the reciprocal value of these points to make that curve, and we have one more point that we can do, and we curve it up like that, and curve it like that, and we have our graph. Let's do another one just to see the process one more time. Okay, we'll try graphing this one. Okay, so I'm going to graph it as y equals x plus 1 to start, so that means that's my graph, and my slope is 1. Cool. I'm going to put my asymptotes. I know it's going to be y equals 0. And then careful, it's actually going to be x can't equal -1. So I'm going to put that. Oh, did I make a mistake? Sorry, those points are in the wrong spot. It should be here. There we go. That makes more sense. Cool. So we got my asymptotes. Now what we're going to do, I'm going to draw that line to connect them. But I don't really care about them. I actually only really care about the point at 1 for each of them, y equals 1. And then I'm going to take the asymptote of, the reciprocal of each of these points. So 2 becomes 1/2, 3 becomes 1/3, etc. So we got our curve, and curve at the rest. Okay, this becomes 1/2, 1/3, etc. And we have our graph. Okay, we'll do this one really quick just so we can see it. I'm going to start at -2. The slope is 4. Cool. Okay. My asymptotes are going to be this 0. My asymptote is also going to be -1/2. Yeah, because 4x minus 2 equals 0. So it would be 2/4, 1/2. Yeah, so it's at 1/2. So that would be right here. Whoa. Sorry, it makes it straighter. There we go. Okay, those are our asymptotes. Then what we're going to do is we're going to take all our points and make them the reciprocals. So 2 becomes 1. 6 becomes 1/6. Oh, sorry. 2 becomes 1/2. There we go. 1/6. Good. And 2 becomes 1/2. 6 becomes 1/6. And we get the curves. There we go. Okay. The last skill that you need to have for this is if you actually take a graph, this graph, and you need to figure out what the equation is. The way that we do this is first we write our asymptotes. Okay. That point where they intersect is going to be a point on the graph. Then we take our values at 1. This is 1 and this is -1. Okay. That is a point and that is a point on my linear relation. Then I'm going to graph the rest of it. It's pretty clear to see that the slope is 2 because the slope is 1. This scale is weird. I'm going to continue the pattern. There we go. Okay. So when I look at that, I can tell what the equation is. Y equals mx plus b. The y-intercept is 4, so it's plus 4. And the slope looks like 1, so it's y equals 1x plus 4. Because it goes up 1 over... Oh, sorry. We got up 1 over 1/2. So that's actually 2. Cool. And it's easier if there's a different scale on your graph. But the process we did was we found the points at 1, we found the points at the asymptote, and we drew a line and saw what it was from there. So let's recap the process. When you get a question like this, you graph the normal graph as if it wasn't reciprocal, so just that denominator part. Then you put the asymptotes on your graph. Then you find the reciprocals of all the points, remember? So we took like 2 and made it into 1/2. Then you can put your y equals 1 and y equals -1 points if you want, and you connect all your points to make it curved. It's always going to look like that for linear. And then you get rid of the normal graph. That actual line at the start wasn't part of it. And that's it. That's how you graph these graphs.